my friends, and welcome to another coaching session. I'm excited as always to get on board and start rocking some of this stuff. And because the last 3 weeks straight, we have been doing critical reading and speed reading and writing and language and grammar, I thought it was about time that we get into some glorious math. And because everyone has enjoyed watching me work through real problems and actually just kind of go through my whole process in the test, I figured that our first math session ever would be the same format. I just go through and start rocking math problems. And today we are going to look at some SAT math. And for those of you who are studying the ACT, again, fret not, because as I've said before, these tests are basically identical now with a couple of formatting differences. So learning how to rock SAT math is exactly the same thing as learning how to rock ACT math, which is a beautiful thing. Now today, I'm going to go through 15 problems on the first ever Practice SAT Section 3 on the College Board website, and I'm going to be going through and showing you my exact process on this super groovy whiteboard here, and you guys all get a chance to see my absolutely terrible handwriting. I'm sure you're very excited to see just how bad my handwriting can be, even after years of using this thing, but that's how it goes. So, with that in mind, what I would like to do is first take a quick look at the math checklist here, because there's a couple of things that I'm not going to be doing today because I know how to solve these problems that I want you to look at. And that is, let's just quickly go through this and figure out what to do if you don't know how to problem, because that's just as important as solving problems that you do know how to solve the right way. Now, the first thing you do is read the entire prompt. So, in other words, go in, if x minus 1 over 3 is k and k is 3, what's the value of x? That is the prompt, right? All the words, all the numbers, everything that's in the problem. Now, if it seemed like something you can solve right away, launch into it. If not, mark it as either long and annoying but doable, or what the heck, and move all the way through the section, first tackling all the problems you think you can solve right away, then going for long annoying, and then going for what the heck. Now, what that means is basically this. Let's say I do 1, okay, I know exactly how to solve this. 2, yeah, I know how to solve this. 3, I know how to solve that. And then you read 4 and you're like, oh, I don't know. That's sort of weird. If that's the case, decide right now. Is it because you just have no idea what the question is asking you at all? Or is it because you know you can solve it, but it's going to take you forever? And you can have any checklist system you want or any marking system you want. So you could say, for instance, okay, if something's going to take me a while, I'm going to put a T next to it for time. And if something is totally impossible, I'm going to put a question mark. So that way you can fly all the way through the section, get to everything you need to get to, and then when you're done, you can scoop all the problems that are easy, because remember, this problem might be insanely easy for you, even though it's technically the quote-unquote hardest problem in the section. It's only the hardest problem because the most people statistically get it wrong. It doesn't mean that it's hard for you. Like if you know how to simplify square roots and this seems simple, it might take you 5 seconds, whereas an easier problem, quote unquote, right, might be really, really tough. Like if you don't know how to rebalance an equation, then number 7 might be practically impossible for you or might take you forever. So just fly through. Okay, 5 is easy, 6 is easy, 7, that's going to take me forever. 8 is easy, 9 is easy, 10, no clue, I hate functions. 11 is easy, 12 is easy, 13, what is even going on here? Okay, I'm gonna put a question mark. 14, easy, 15, that's gonna take me a while. Keep going through, get all the points you can, then go back and solve the stuff where you can do it, but it's going to take more time. Then take a crack at the stuff where you have absolutely no freaking idea how to do it in the first place. That's the most efficient way to go through a math section. Scoop everything you know how to solve with certainty, because if you know how to do it, then you're in good shape already. That's 90% of the battle on this test. Then, once you've solved the stuff you know how to do, go in and solve the stuff that you know how to do but might take you a while. And finally, spend your time cranking through the stuff that might be a little bit weird or that you don't really know how to deal with at all. So that's the process there for the checklist. Now, what you want to do is here also, I want to go through. For all problems you solve, remember to read the entire prompt all the way through to get a full feel for the problem and what it's really asking. And then, before you do anything else, look at the answer choices. Obviously, this only applies when it's multiple choice, right? Not for filling your own answer, but you want to use the answer choices instantly to give you a sense of the format that the answers are in, because that's going to help you to solve the problem. It's going to help you to know what kind of format the answers are in, and it's going to start churning your brain and showing you what you can use and what you can't. So, for instance, if you look at this, before you do anything for number 2, first realize, okay, I is in every single one of these answers. That will immediately tell you, as we'll see in a second, that there's going to be no simplifications of I, and you're just going to be leaving I as its own variable. Right? If you look here, you might have a really tough time coming up on your own until you realize, okay, it's actually explaining all the different possible answer choices to you and giving them to you right up front. So look at the answers immediately so that you know exactly what they look like. Do they have a square root in them? Do they all have 3 in them? Do they all have the variable j in them? Whatever it is, go through and get a feel for all of these guys. And then the next thing is, read the prompt again and separate the question from the prompt. I'm going to show you exactly how I do that moving forward. But the basic idea here is there's a big difference between the prompt, which is all the words here and all the figures and everything, and then the question. The question here is just, what is X? Or X equals question mark, right? That's the question, and it's huge to actually segregate this so you, A, can keep your eye on the prize, know what the final sort of mark is that you're going for, and B, so that you don't make what I call the pencil down syndrome, where basically you spend all this time, figuring something out. You're like, oh my gosh, all right, K plus 1 is 7. Okay, and then you do everything, you find the hard thing, and then you forget that the question is actually what's X, or what's X minus 1, or what's J over M, even though J was the hard thing to figure out. So make sure that you actually write what you're looking for above the problem so that you keep it in mind. And then from there, I want you to just look through the rest of this checklist, but we're going to be going through all the rest of this stuff on our own. I wanted to go through the first part just so you remember how to navigate a section and so that you're as efficient as possible. But with that in mind, without any further ado, let's dive right in and learn how we can start rocking the first 15 problems on this test. And throughout the way, I'm going to be showing you all of my tricks and how I go through all of this groovy stuff. So the first one, if x over 1 is 3, if x over 1 over 3 equals k, and k equals 3, what's the value of x? All right, so immediately we write x equals what? That is what we're trying to solve. Next up, we know that k is 3, so we can just literally say x minus 1 over k, right? Or over 3 is k, apologies. 3 is k. And you might say, I can do this in my head, right? Well, guess what? I sort of can do it in my head too. It doesn't matter. You need to write out every single step. So many of my very smart students get terrible scores on these tests at first because they think that they should do stuff in their head. It's like proving that they're smart and proving that they can save time. But the amount of time you save skipping steps and not writing stuff down will absolutely bite you more than it will help you. I cannot tell you how important it is that you write out every single step. Next thing I know is that k is 3, so then I plug it in. And you might say, come on, I already know that x minus 1 equals 9. I don't care. Write it out anyway. See it all happen, and you're going to make way fewer mistakes, and you're going to miss a lot less. Then we multiply everything by 3. Boom, x minus 1 is 9. Add 1, and x equals 10, right? So we reference it. Hiya, there it is. 10 is the answer, and we're good to go. So pretty easy algebra problem, but the big thing to remember is define what you're trying to find and go through every single step. Number 2, I is the square root of negative 1, which is what it always is. They're saying it's just not a variable I. It means I is in the imaginary number. What's the sum of 7 plus 3i plus negative 8 plus 9i? And then we have a bunch of simplifications here. Now, in this case, we actually can do something kind of funky. We don't need to write everything down because we actually can be more methodical using elimination. So check this out. We know that these are grouped. This is addition, it's not multiplication, right? So all we need to use is the additive property. And what we have is 7 plus negative 8, right? And then everything else is just i's, right? These are the whole numbers that are not kind of attached to imaginary numbers. So what is 7 plus negative 8 or 7 minus 8? That is negative 1. We see that this and this have -1. These two do not. So we can kill C and D, right? And we're just left with A and B. And then we look and we say, okay, 3i plus positive 9i, that's 12i, right? 3 plus 9 is 12. So in this case, it's actually more methodical to just do it step by step. And A is the answer. And you might notice a contradiction saying, well, wait, didn't you say to write everything down? That's true when you're doing algebra or when you're doing things that take multiple steps to work through. You don't want to sort of skip. You don't want to say, okay, K is 3, I see that there, and then, okay, all of a sudden X minus 1 is 9. Even though that's the case, you're skipping too many steps. But if you're being hyper methodical about it, you're going one bit at a time, right? All right, 7, -8, -1, all right. Then you can do it that way. That's fine. Next up, number 3. On Saturday afternoon, Armand sent M text messages each hour for 5 hours, and Tyrone sent P text messages each hour for 4 hours, which is following represents the total number of messages sent by Armand and Tyrone on Saturday afternoon. All right, and then we have these 4 variable heavy setups. Now, even though this one seems easy, what I want to do is, again, figure out all messages sent, right? Or total number of mess, right? I'm going to put it down really quick, know exactly what I'm looking for, and then I'm going to make up numbers. Even though it's an easy problem, I don't care. I still want to make up numbers anytime I have variables in the answer and I'm not actually solving for the variables themselves. So it says that Armand sent M messages each hour for 5 hours, right? So here's what I'm going to say. M is 5. He sent 5 messages each hour, and he did it for 5 hours, right? So how many messages total did Armand send? Well, 5 hours, or 5 messages each hour for 5 hours. He sent 25 messages. Next up, we have Tyrone. He sent P text messages each hour, and remember we have each hour, for 4 hours. So let's say that P is 7, right? I'm picking weird numbers, by the way, that are prime numbers so that they don't interact very well with each other, and I'm not going to get false positives. So he sends 7 messages every hour for 4 hours. Multiply these, right? And what I get is 28 messages. And then I just add these together. 25 plus 28 is 53. Now, all I need to remember is M is 5, P is 7, right? And I'm going to find 53 as my answer. That is the total number of messages, and that's what I'm looking for. So with M is 5, P is 7, which of these gives me 53, right? And okay, 5 times 7 is 35 times 9 is way bigger than 53. This is dead. I know that this, again, is going to be way, way, way bigger than what I'm looking for. Then I have 5 times 5 plus 4 times 7, that's exactly what I wanted in the first place, right? Because I just did that math. I know C is the answer. And because this is different, I can't have 2 right answers. That is wrong. It does not add up to 53. And at this point, you might be saying, come on, ma'am. I already knew to do that math, right? Like, I already knew that it was just 5M plus 4P. And here's what's funny. If that's the case, then fantastic, right? Go for it. But the thing is that number 3, this is going to be a pretty easy problem. You know that already, right? So if you know you're going to be sure of the process, then just go in and take a peek. You might just see it already. But most of the time, even on really simple processes, they actually sort of try to obscure it. So if you're not 100% confident, just find a real number because you know 53 is the answer. And then by going through the math, you realize, oh, it was 5M plus 4P. That's what we're going for. And then you see it there. So sometimes it's really obvious in hindsight, but you don't see that that's how you solve it right away going through the first time. All right, number 4. Kathy is a repair technician for a phone company. Each week, she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated with the equation P is 108 minus 23D, where P is the number of phones left, and D is the number of days where she's worked that week. What is the meaning of the value 108 in this equation? So again, I realize these are possible options for what 108 means. I would write 108 means, question mark, right? What does 108 stand for? Just so I do not get confused. I don't start to think, oh wait, is that what P stands for? That's what D stands for, whatever. 108 is what I want to define. That's what I want to figure out. Okay, so we look here, and the basic thing here is we can't plug anything in. We can't do math per se, but we can eliminate these guys. So let's go one by one. Does it mean that you will complete the repairs within 108 days? Well, how does that make any sense at all? Because it already says each week, right, she gets this batch of phones, and the number of phones she has left to fix at the end of each day can be estimated here. So this only takes place over a 5 to 7 day period. Are we seriously saying that she has 108 days? How would 108 days affect the number of phones? That's terrible. She starts each week with 108 phones to fix. All right. Remember that P is the number of phones she has left, right? This is 108 minus 23D, and D is the number of days she has worked that week, right? So what we see here is that 108 keeps getting chunked out of each day she moves. That makes a lot of sense, right? If she works one day, she probably fixes 23 phones. That's what I would assume that means. We'll leave that. C, Kathy repairs phones at the rate of 108 per hour. Hours isn't even in this equation. That's dead. And Kathy repairs phones at a rate of 108 per day. No, that makes absolutely zero sense because 108 isn't tied to anything and this isn't a daily setup. So what this equation ends up saying is that she has a certain number of phones left per week. She gets 108 phones each week, and each day she repairs 23. Now, you might have just, again, automatically seen that this was the way to do it, but if you don't see that right away, the trick is to try and rip these apart, figure out why they're wrong. A, C, and D all stink, so we can kill them, and we're left with B. Next up, number 5. Which of the following is equivalent to the expression above? All right, here's another beautiful situation where we can do grouping and look right at the answers here, right, to start eliminating without spending too much time on this kind of problem, which is awesome. So the first thing I want to do is find similar terms. All right, here it is. X squared y, right, I have here. And then here, I also have x squared y. And what I notice is that it's x squared y minus negative x squared y, right? So whatever we're left with has to have 2 x squared y. Does that make sense? Because we have x squared y here, then we're subtracting a negative version of it, so we're adding it to itself, and we get 2x squared y. That means that we have to have either C or D as the answer, and we can immediately kill A and B, right? Next up, we have y squared. 3y squared, right? That's its own setup. And then we have negative 3y squared minus negative 3y squared, right? If you subtract the same thing from itself, what you end up with is 0, right? This is the same thing as adding 3y squared to negative 3y squared. So we end up with no y squareds at all, which, boom, means that D is dead, C is the answer. Now, that's how we use answer choices to move really, really, really quickly. Because we didn't even have to do all of this. I didn't need to write it all down. I didn't need to go through every step. I used elimination, and I didn't even have to deal with all the xy squared stuff. And if you want to check it out, right, here's 5xy squared, right? And then I'm subtracting positive 3xy squared, and I end up with 2xy squared. So I end up getting this anyway, but I didn't even have to do that step because I'm just eliminating to be way faster. All right, number 6. Pediatrician uses the model above, h equals 3a plus 28.6 to estimate the height of a boy, h in inches, in terms of the boy's age, a, in years, between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? All right, our answer choices are just these guys. What I'm going to write is how much up a year, right? It's just something to say that I'm trying to figure out how much in height does a boy grow each year from the ages of 2 to 5. Now, this is total height, right? And what I have here is that every year you add 3a to 28.6. Well, this one is just pretty freaking obvious, right? 3 works like a charm, basically. I mean, look, you're basically saying that when a boy is 2, he's probably on average 28.6 inches, right? And I'm going to guess that he grows about 3 inches a year between the ages of 2 and 5. That seems to make sense. Where does 5.7 come from? Where does 9.5 or 14.3 come from? I don't even know where they get these numbers, and they don't really have anything to do with anything. So these are pretty easy to eliminate. A makes a lot of sense. We go with that one. Number 7. This is beautiful because this shows a really, really, really funky kind of trick that will save you an insane amount of time, which is basically taking stuff like this, unbelievably complicated looking equations, and chunking them into symbols to make everything way, way, way easier. And it would be even cooler if I could draw right on here, but I want to show you how this works by first setting up this equation on the other page really quick. So m, let me clear this guy, equals, and then we have r over 1200. Sorry, again, my handwriting is the worst in town, and I apologize. Someday I'll get lessons. 1 plus r over 1200 to the n. Oh, geez. All right. This is why I need to get better handwriting. And my old man memory. It's already taking a toll on me. 1 plus r over 1200 to the n. And then we have got 1 plus r over 1200 to the n. Minus 1. All right. And then we also have p. Okay. Here's how you can solve something like this ridiculously simply, now that I've spent all that time doing that. The formula gives all this stuff. Monthly payment M, need to pay off a loan of P dollars and R percent, annual interest over N months. And at this point you might be thinking, oh my gosh, I don't know the interest formula, that's so much math, how am I gonna do this? But then you realize that the question, which of the following gives P in terms of M, R, and N? So in other words, whenever you see something like this, which gives something in terms of something else, it's just asking, what does this thing equal, right? So all we're actually solving is P equals what? And in an algebraic setup like this, all we really need to do is get it on its own, right? That's all we need to do. So here's what's really cool. I'm just going to make sure that I group everything into parentheses like so. I'm going to say this is the purple bracket, this is the green bracket, and I'm going to say that this is the yellow bracket. And all of this stuff is just grouped. Now here's what's funky. What I can do now is just shift everything around algebraically, and I'm going to show you why this is so sort of awesome, because now I want to get P by itself. I don't even want to write all this stuff again. You already saw how much I struggled the last time. So here's what I'm going to do. P times, and what I saw was that the green bracket and the yellow bracket are multiplied, right? By the way, you don't have colors on the SAT, but what you do have is stars or shapes. So you can just say like, this is star, right? This is triangle, and this is, let's say square, right? So in fact, just to show you how you can do it on the SAT even easier, I'm just gonna shift this. Let's say that I multiply both sides by the square bracket, right? What I get is P times triangle times star, these two guys, because remember when you multiply the denominator out of a fraction, you just end up with the numerators and this is still multiplied by them. That equals M times square, right? All right. And now I want to get P by itself. So I'm just going to divide it by star triangle. And what I get is P equals M square over star triangle. Now I could have done all the math, right, and done all these different writings and gone crazy, but all I'm trying to do is get P by itself in the most simple way possible and save myself some time. So let's look, which of these has P on its own and then has star triangle in the denominator? Which one of those is the case? So remember, this is star and triangle, right? So, no, neither of these work, but look at this. Suddenly what I have is r over 1200 and 1 plus r over 1200 to the n in the denominator. That's the only one that has those in the denominator. That's the answer. And by the way, just so I can show you what I mean, we also need m times square, or m times this, 1 plus r over 1200 to the n minus 1 in the numerator. And voila, that's exactly what we have right here in the top. So remember, for algebra, all you can do is take every major constituent piece, shift it around, and then you don't have to do any difficult math or really put that much work in. You're just shifting around blocks as long as you're grouping them in parentheses. And that's why I drew these sort of illustrated parentheses in the first place, to just show you that you can take all of this stuff, 1 plus r over 1200 to the n minus 1, and treat it all as like one variable that you call square, shift it around, save some time, and boom, you end up with the answer. The most important thing also to remember is, again, whenever they ask which of the following gives something in terms of something else, you're just finding that thing on its own. All right, onward and upward. Number 8, if a over b is 2, what's the value of 4b over a? All right, again, you know how obsessed I am with making up numbers, right? I always try to do that. Now, we're never going to know what a or b are. We don't find them out. All of the answer choices are just these guys. I'm also going to realize that I want 4b over a. That's what I'm trying to find. That is the solution to the problem, right? So all I know is that a over b is 2. That's it, right? So I'm just going to make up numbers and make it true. I know that a over b is 2. So I'm going to say that a is 6 and b is 3, right? That works. Cool. So now, what is 4b over a in that case? Well, what's 4 times 3 over 6? That is 12 over 6, and that is 2. My answer is 2, right? And voila, look at that. That's the answer. And the cool thing is, I don't even have to worry about getting false positives here, because in this case, right, I don't even see that there's B or A in the answer choices. Like, that's the only thing that work. There can't be 2 right answers, so there it is. It doesn't matter what numbers I make up, so long as A over B is 2, that's what we're gonna get. Alrighty, next up, number 9. What is the solution xy to the system of equations above? All right, this is pretty funky. So in this case, we want to find the solution. We don't need to graph these. We can't use our calculator. We don't need to do any complicated algebra. All we need to do is plug them in, remembering that the first number is x, second number is y, and they need to work for both of them, right? What it means when a coordinate point is the solution to a system of equations. What that means is that these work for the x and the y in both cases, and in both cases give you the exact answer that the equation's coming up with. So all I'm going to do is start testing, and I'm going to start testing on the easiest one here, right? So, okay, x is -5, right? -5, well, that's 5, right? And y is -2, that's positive. So -5, right? Or sorry, +5, nope. A is already dead. Like, it already doesn't work for this one. I don't need to test it on this top one. And by the way, I'm testing this because it's simpler, right? So now I go to B. I'm again going to test the easy one. All right, I know that x is 3, right? So -3, and then -8. Okay, what's -8 times 2? -16. -3, -19. All right, checks out for this one. Now I move on to this guy. Does it work here? X is 3. Okay, 3 times 3, 9, plus -8 times 4. That's -32. What's 9 minus 32? That is -23. And boom, we have our answer, right? All I did was tried to plug this in. Didn't work. So it's dead. Then I went to the next one, plugged it in, worked. Plugged it in here, it worked. And because this works on both, I can't have 2 right answers. This is good to go. The answer here is B. Alrighty, next up. Number 10, g of x. The function g of x is ax squared plus 24. All right, for the function g defined above, a is a constant. That means, by the way, that a is just always has the same value, right? And g of 4 is 8. What's the value of g of -4? So first, what I want to do is figure out exactly what I'm solving, which is g of -4. When I put -4 into this function, what do I get? I also realize that all of these are actual numerical answers, so I'm actually going to be solving these. There's no variables involved. I'm going to get a real number answer here. So what I also know is that g of 4 is 8. So what I have here is the actual function, which is g of x. Remember, x just stands for the input is a times the input squared plus, I believe it was 24. Boom. And then what I have is that g of 4 is 8. All right. Well, this is easy enough. Remember, all you want to think about these like is that they are inputs. There's no such thing as x. X means thing I put in the function. So you want to sort of imagine it like this. Put thing into function, and what you get is a times thing squared plus 24. Now, 4 is the new thing, right? So that's the thing that gets squared, right? Oh, sorry. G of 4 is 8, and the actual directions are like so. G of input equals a times input squared plus 24. And the input, in this case, is 4. Right? So now what we realize is that these two things are equal to each other. You can have two different solutions for G of 4. So now I just set them equal to each other. 8 equals a times 4 squared plus 24. All right, that gets to 8 equals 16a plus 24. All right, a then can only equal one thing. I subtract 24 from both sides, I get negative 16 equals, right, 16a. So a equals negative 1. Boom. That's what a equals. And now what they want to know is, what is the value of g negative 4? So just different input, right? What is g of negative 4? Again, I'm setting this all up. And I'm just putting in the new input here. Negative 4. And I'm going to make sure that this is negative 4 in parentheses so we don't mess up the negative. Now, the other cool thing is we also realize that a now is just negative 1, right? So what we could do here is simplify these. Negative 1 times, and negative 4 squared is 16, plus 24. All right, g of negative 4 is just 24 minus 16. Again, it is 8. And that is what we wanted in the first place. Shabam. The answer, again, is just 8. Right? So the answer for number 10 is A. And the trick here is that there's a bunch of tricks, actually. First thing, notice that negative 1 is one of the answers. This is exactly why it's so unbelievably important to write what you're actually trying to get up front. Because X was the thing that was, or A rather, was the thing that was kind of tough to solve. So you might go, oh my gosh, A is negative 1. Yes, I got it. And then boom, you go in here and you're wrong, right? You needed to plug it back in. Also notice that they have negative 8 here, these sneaks, because you might go, oh, okay, well, if I put in positive 4, I get 8. If I put in negative 4, I just get negative 8. That's not how functions work. You have to follow each step. They are weird mistresses. You have to go through and actually solve them. You can't take shortcuts with functions. So that is how you solve that guy. Just remember that X stands for input, and you're good to go. Next up. 11. In the equation above, B and C represent the price per pound in dollars of beef and chicken, respectively. Respectively, by the way, means in that order. So B is beef, C is chicken. X weeks after July 1st during last summer, what was the price per pound of beef when it was equal to the price of pound per chicken? Okay. Now, again, why is it so important to write what you're finding up front, right? Like, what value of B equaled C? I'm going to show you why it's so important that I'm doing that in a second. This is the classic SAT and ACT tricky maneuvering at its absolute finest. Okay, so they want to know when the price of beef was equal to the price of chicken. Now here's what's cool. These also equal the price of beef and the price of chicken, right, during a certain period. So what we can do if we want to find out when they're equal is set them equal to each other, right? So 2.35 plus 0.25x That was the price of beef. We want to know when it equals chicken, and that was 1.75 plus 0.4. 4x. We can set these equal to each other because we're trying to figure out when they did equal each other. So that's always how you solve these. Set them equal. Next up, we simplify, right? I can do it long form on paper. This is, unfortunately, the no calculator section, so we need to do a little bit of long form math. First step I'm going to do is subtract minus 1.75, or I'm going to subtract 1.75. And what I end up with is 0.25 plus 0.35, 0.6. 0.6 plus 0.25x equals 0.4x. Then I'm going to subtract 0.25, right? And I get 0.6 equals 0.15x. And then from here, a nice little trick, because this doesn't round up nicely, is I'm just going to multiply them both really quickly by 100 to get rid of the decimals, right? So what I get here now is I move it over 2, and I get 60 equals 15x. Right? Just moving this over, boom, boom, and this over, boom, boom, I added 0, right? So 60 equals 15x. That means that x equals, if I divide them both by 15, 4. Now, I wouldn't be surprised if somehow 4 was an answer. In this case, they weren't that sneaky. Right? Now what I know is that 4 weeks after July 1st, they were the same price. That's what I figured out. And now all I have to do is plug it in. And I'm going to do it with the easier one. So this, I think, is the easiest equation. 2.35 plus 0.25x, right? I obviously think this is easiest because I know that x is 4. So in this case, if I plug 4 in for x, what I get is 2.35 plus 1, or 3.35. And that is D. And that's our answer. So again, just to recap, for these ones where they say, Cherie sold this many cherry lollipops and this many, gummy bears, and, she ended up making the same amount of money from both of them. They always have problems like this. They have different setups, but all you do is set them equal to each other, right? Find out what the variable that they have in common with each other equals by setting them equal and then plugging it back in. That's how we solve this, right? By the way, if I plugged 4 in here, I would also get 335. I could plug it in for either, but just notice that it's really important, especially in the no calculator section, that I'm doing the math that's easiest. I know that a quarter times 4 is going to equal 1, whereas this is going to be 1.6, and then I'm going to have to add it all up and blah, blah, blah. Alrighty, number 12. A line in the xy plane passes through the origin and has a slope of 1 over 7. Which of the following points lies on the line? All right. Now, for this one, I want you to remember that when something passes through the origin, passes through the center here at 0, 0, and a slope of 1 over 7, remember always that it's rise over run, right? And here it means it goes up 1 over 7. So basically, 1, 2, 3, 4, 5, 6, 7. Here would be a point on the line, and then down 1 over 7. 1, 2, 3, 4, 5, 6, 7. Hiya. We have this here. And what I want to do is just quickly show you, in this case, how you can map out 2 points. What we have here is, remember x first, 7, 1. And we also have here is negative 7, negative 1. And what you'll notice is that there's a relationship here. The relationship is that the x value is always 7 times the y value. Same here. X value, 7 times y value. Now if I look here, is the x value 7 times the y value? It is not, right? So that is not going to work. Is the x value 7 times? Nope. It is actually 1/7. That's not going to work. Is it equal? Nope. And is the x value here 7 times the y value? Yes. So the cool thing is I don't need to map this all out or go through every single one of these points. What you do in questions like this is you just figure out the relationship between x and y, because slopes are a ratio. They're expressed as a ratio for a reason. And the tricky thing here is to realize that, it's so tempting to go, oh yeah, it's 1/7, right? In that case, this would be very, very tempting. But no, You want to actually map it out, find 2 points, figure out the direct relationship between x and y, and once you do that, then just find the point that matches. If you do that, you're going to be in fantastic shape. 3 more for the day. Here's where they get a little bit tough. Or do they? All right, so 13. If x is greater than 3, which of the following is equivalent to this insane nightmare? And then I notice that, of course, we have all these different options for us. All right, we know that x is greater than 3, right? So first thing I'm going to do is I'm going to make up a number, right? They are not asking us to solve for x. They're asking us to plug x into a different equation. This is exactly why you always want to be asking yourself, can I make up a number here? Because if you can, you should, your life is going to be a zillion times easier. Now, I look at the actual equation, which is 1 over x over 2. For x plus 2. Plus, correct, 1 over x plus 3. Which then equals, if I plug 4 in for x, 1 over 1/6 plus 1/7. Now, I'm going to create common denominators, right? 42, right, is their least common multiple, right? And you just multiply them over. So what I end up getting is 1 over 7 42s plus 6 42s, right? Which then equals 1 over 13 42nds, right? Now, what happens when you divide 1 by a fraction or any number by a fraction? It's the same as multiplying it by its reciprocal. So this is the same as 1 times 42 over 13. And because 13 is a prime number, right, we know that this is irreducible. So our answer when x equals 4 is 42 over 13. That's what we're looking for. Right now, all we need to do is plug x in and see if that's the case. Here's what's really awesome. I always want to go for eliminating the ones that obviously aren't going to be the case. We have, in this case, if x equals 4, an irreducible fraction, right? Is this going to be a fraction at all? No, it's going to be a whole number. Is this going to be a fraction? No, it's going to be a whole number. C and D are dead. So now, all we need to do is test stuff out. And then here's another really, really, really fun trick that makes this even faster instead of doing a ton of work. We also know that because we found this stuff, the numerator is larger than the denominator. So because the numerator is larger than the denominator, we want to find a numerator that's larger than the denominator. Which one is that? Obviously, it's going to be this one. It's going to be B, right? I'm confident enough in my math at this point to not even do this, but just to prove it to you. It's kind of funky. X squared plus 5x plus 6 over 2x plus 5 is, remember, x is 4, 16 plus 20 plus 6 over 13. Simplifies to 42 over 13. And look at that. That is the right answer, and we don't have to test choice A because obviously it's switched these around. That's not going to be the case. So once you get more and more used to coming up with your own numbers, this is going to be more and more of a breeze, and you always want to be looking for this opportunity. Now, you might be confident enough with your algebra to try to do this some other way, but I really ask you not to do that. You will always get the right answer. If you just plug in numbers, suddenly you're working with real numbers. I never did anything tough. I just needed to know how to create, a common denominator, right? I needed to know that if you divide something by a fraction, it's the same as multiplying it by a reciprocal. And from there, I have real numbers to work with, real numbers to test. And because I'm working with real numbers, by the way, it also shows me when I can eliminate really easily. In other words, if I still had some insane algebraic setup, I might not know what to eliminate. But because I know that the answer is, period, it's 42 over 13, like that's what I want, I know automatically that this is not going to work. It's not a fraction. This isn't going to work. It's not a fraction. And I also know that this isn't going to work because the numerator is smaller than the denominator because x is 4. That's how you do it. Okay, number 14. If 3x minus y is 12, let's set this guy all up. 3x minus y is 12. They want to know, what's the value of 8 to the x over 2 to the y? And this literally is my answer, whatever I have here. Now, I have three options. I have 2 to the 12th, 4 to the 4th, 8 to the squared, or 8 to the squared, 8 squared, and the value cannot be determined from the information given. Very tempting, because you go, oh my gosh, I don't really know how I can solve for x or y here, and now they want this crazy thing with exponents. How the heck do I do that? All right, this is one of the rare opportunities on the SAT and ACT where when you see it, it's a weird trick. If you haven't seen it before, you're probably never going to get it right, but once you have seen it, you're going to nail it every time. And it's when you're dealing with exponents. What you always want to do is group the exponents so that they have the same base. And here's what I mean. 2 and 3 are the ones they use most common. So notice that 2 can be taken with an exponent to 8, right? Here's all I want to show you. 2 to the 3rd equals 8, right? So with that in mind, and by the way, you might get hinted to this from the answer choices as well. Very sneaky about kind of subtly hinting if you know where to look. So would you agree then that 2 to the 3rd equals 8? Then if I'm going to try to find this, I can write it this way. 2 to the 3rd to the x over 2 to the y is something. Well, of course, right? There's no difference between 8 and 2 to the 3rd. I just put in exactly the same thing. So now I have a much, much easier setup, but I'm still not quite there. The next thing I want to do is simplify this a little bit. Remember, when you take an exponent to another exponent, you multiply them, right? So what I'm trying to find is 2 to the 3x over 2 to the y. All right. Now that's what I want. But I have another step. I also can figure out what y equals, right? I can do that by just solving for y here. So what I'm going to do is add y to both sides, and I get 3x is 12 plus y. And then I'm going to get 12 out of there, subtract it from both sides. 3x minus 12 is y. Hiya. So now would you agree that my new thing, because this literally is what y equals, is 2 to the 3x over 2 to the 3x minus 12. A little bit simpler, huh? Now I just have one variable. And here's where it gets even cooler. What happens whenever you have the same base, right? In this case, 2. And then you have different exponents in a numerator and denominator. And if you need a little reminder, it looks something like this. If I have like x to the 5 over x to the 3, I subtract them, right? I subtract this from that, and I get x squared. So all I'm going to do now is subtract these from each other. What this ends up equaling is 2 to the 3x minus 3x minus 12, which simplifies to 2 to the, well, the 3x's cancel, and this is now minus negative 12. 12. I add it. Boom. That is my answer. And if I look above, that would be A. Pretty funky, right? So, quick little recap here that's super awesome, which is that whenever you see weird exponents that don't match or are insane, and you're like, how could I possibly begin to do this? Look for this trick. The same thing holds true if they have something like, 2 to the j and then like 16 to the L plus P, right? It looks super impossible, but you realize that's actually 2 to the j and then 2 to the 4th to the L plus P. And suddenly you have the same base. They'll do it with 3 sometimes also, right? They'll have, 3 to the x and 27 to the y. But remember, you need the same base to use any exponent math. So something that's just 3 to the x and 3 to the 3rd to the y, right? And then, of course, you just multiply these, or 3 to the 3y. That's all there is to it. And remember, as a quick review, that the exponents that you're sort of expected to remember in your head are basically 2 going up to 32, right? Like it goes 2, 4, 8, 16, 32, sometimes 64. And then for 3, generally they'll only take it to 81. Sometimes they'll take it to 243, right? So if you just remember those, right, it's like 3 squared is 9, to the 3rd, right, is 27, to the 4th is 81, and to the 5th is 241. If you just remember those, you're going to be able to do these every time and instantly recognize them. Like if you see 3 as a exponent base and 241, you should know that this is probably the trick. I realize it's extremely specific, but a lot of stuff on the SAT is. All right, last but not least, my favorite kind of problem, the kind of problem that is practically impossible to solve if you've never seen it before, and insanely easy to solve once you have seen it and done it once. So if ax plus 2 times bx plus 7 is 15x squared plus cx plus 14 for all values of x, and a plus b is 8, what are 2 possible values for c? All right, first of all, again, I'm never going to break my habits. C equals what? Right? What are my c values? That's what I'm solving for, c. Now I have these options. Apparently there are 2 values and there's sets of them and I have no idea. So here's a cool rule. Remember, whenever things are factored, right, you want to try and smash them together. And whenever things are smashed together, you want to try and factor them. In this case, I want to distribute these, right? So I have ax plus 2 times bx plus 7. And again, you're going to have to bear with me for a second here. Ax plus 2 times bx plus 7 equals 15x squared plus cx plus 14. All right, first thing I'm going to do is I'm just going to distribute these beasts. So here's what I get. I do this and I get abx squared, right? Then I do this, right? And I get plus 2bx. Then I do this, and I get plus 7ax. And then I do this, and I get plus 14. Boom. And that equals exactly what I had beforehand. 15x squared plus cx plus 14. Now, this gets pretty cool. What do they have in common on both sides? Algebra 101, whenever you have exactly the same thing on both sides, you get rid of it. 14 is added to both sides, so I can just kill it, right? Now, here's an even cooler thing. Every single element of both sides here is multiplied by x. So I have a massive, massive, massive simplification here, right? Which is that at this point, I can even divide everything by x, right? Because it goes into every single element. Remember, when things are separated by addition or subtraction marks, you need to be very careful that you don't do this willy-nilly, but because x goes into everything, I can divide x out of this whole thing. And here's what I get. I get abx plus 2b plus 7a equals 15x plus c. All right. Now, this still isn't totally comprehensible. I'm still not all the way there yet, but I do have something cool, which is that, first of all, it's a lot easier to look at, and B, I'm very close, because I still have one more piece of information here. The other piece of information I have is that A plus B is 8, right? So, I'm going to write that down here. Shabam. A plus B equals 8. And now, I need to do a little bit of thinking. And here's the really cool thing here. I know that A plus B equals 8, right? And I know also that there's a little bit of a shared setup here. I want you to think about it like that. The only thing that X has in common on both sides is this, all right? So what we're basically seeing here is that 2B plus 7A must equal C, but whatever ABX is also has to be 15X. So check it out. AB, A times B, has to equal 15. Right? Now, what are two numbers that add up to 8 and multiply to 15, right? And I have 1 and 7, no. 2 and 6, no. 3 and 5. 3 and 5 certainly do the trick. So check it out. would you agree with me here that A could equal 3 and B could equal 5, or B could equal 5 and A could equal 3? Again, how did I find that? Pretty much the same way that you FOIL something or that you factor any equation, right? You're looking at the sum and the product here. I know that because these kind of pair up with x, right? These are the coefficients of x here, and this is the coefficient here, right? This isn't going to spread out randomly. It's not like there's going to be a different thing pairing with x somewhere. These have to match with each other, right? So that's how I get to this conclusion. I know that a plus b equals 8 because they told me, and I know that a times b equals 15 because otherwise it won't match. Then I just do some simple math, and I figure out that these are the two possibilities. So check it out. First thing I'm going to do, I'm going to solve this with a equals 3 and b equals 5, right? And here's what I get. 3 times 5 times x plus, right, b is 5. 10 plus, all right, a is 3. 21 equals 15x plus c. All right, now check it out. This is 15x, right? Plus 31 equals 15x plus c. Could c equal 31? Yes, it could. And check it out. Boom! This is the only one that matches. But just to show you the magic, I also want to show you the other way around. Right? What if we did b is 5 and a is 3? Right? So then we get, okay, let's see here. 3 times 5x x plus, all right, b is 5. Or sorry. Oh, geez. I realized I was saying something silly. B could be 3 and A could be 5. I wrote them in the wrong order. They could be opposites. Sorry if that was super confusing. I apologize right at the end of a session. I get tired too sometimes, guys. So I should have wrote these next to each other or written these next to each other like so. A could equal 3 and B can equal 5. Or A could equal 5 and B can equal 3. That's why there's a little bit of confusion. I apologize. I was not writing that very clearly. If that threw you for a loop, my bad. I wrote the same thing out here before. All right, so now let's try it out with b equaling 3 here, right? And if b equals 3, we still get 15x plus 6 plus 35 equals 15x plus c. And all right, now we have these setups here. 15x is dead. C equals 35 plus 6 or 41. And that is the other option. So again, definitely watch through this all again, especially once I put it in the library to kind of get a feel for how you solve these. But just as a recap, these ones are pretty much the hardest problem you're ever going to see on the SAT. You'll actually see them quite a bit, but they have pretty much the same format every time, which is first distribute, then kill anything that they share in common, in this case the 14. Then divide out the number as much as you can, and then just realize that coefficients have to match, right? So like once we get to the point where we know that there's just x here at 15 and abx, you know that ab must equal 15, and you can go from there. So, I've been going pretty quickly. That was a good hour of insane math, and I hope that you got a good idea for how I'm going through everything. It's very methodical. I'm trying to make sure I can always use the answer choices whenever possible. I'm always defining what I'm trying to find. In this case, C, right? I'm always trying to eliminate when I can. I'm always trying to make up numbers when I possibly can. And I'm just trying to be strategic. You'll notice, if you think back, I never once this entire session just started doing math, quote unquote. Like I never just solve the problem at face value. That's an insane waste of time. Instead, what I'm trying to do is just use what they're giving me in terms of, can I make up a number? Can I eliminate? And just be as quick as possible and do as little math as possible to get to the answer, because it's all about the answer and that's it. So I had a lot of fun. As per usual, I'm going to have some more funky math stuff that dives into actually some of the specifics of what we covered today. next week. But for now, I would like you to, after this, if you have the time, just go through a few math problems and get in the groove, and also be sure to read the math checklist. You want to be living and breathing these checklists, and if you can get in the habit of using them every time, reviewing them beforehand, and then kind of going through and being as strategic as you possibly can, you're going to have a way easier time, and this section is going to be really easy before you know it. And on a quick side note, I would like you also, if you've been taking notes on these problems, to make flashcards of any of the ones that you didn't know how to solve, so that you have them in your memory bank and you can use them later on. I'm signing off. I hope you have a glorious evening, and I'll see you next week. Cheers.